Every battery you own is quietly dying right now, and the way it dies is hidden in a war of atoms most people never see. Meet the battlefield. Crack open a cell and you find three layers: a graphite anode, a chemical sea called the electrolyte, and a metal oxide cathode. Charge it, and a swarm of lithium ions drifts across that sea and tucks itself into the graphite. Discharge, and they rush back. Every charge, every single day, that tiny shuttle runs again. Keep this picture in your head because everything that follows is what happens when that shuttle goes wrong. Every battery is hunted by two villains. The first, cycle aging, attacks while you use it. Each charge and discharge wears it down. The second, calendar aging, is stranger. It kills slowly even in a drawer, switched off, untouched. Time alone is enough. By the end, both leave the same scar. And the first thing that goes wrong is heat. Watch warmth bloom through that very same cell, and as it spreads, the chemistry inside speeds up. Roughly every 10 degrees Celsius doubles the rate of aging. A car baking in the sun can hit nearly 60 degrees inside, quietly cooking your battery's life away. Heat is the silent killer. Keep it cool, and it lasts. Heat doesn't just speed things up, it feeds a crust. Even sitting idle, a battery is quietly dying because a microscopic skin called the SEI creeps over the anode, trapping lithium forever. It grows with the square root of time, so the fastest damage happens early, and the worst of it when the cell is full and hot. Cool and half-charged, it barely ages. Hot and full, it crumbles. And here is the cruel twist of resting. Even a battery doing nothing is making a choice. Fill the anode to the brim and its potential drops near 0 volts, where the electrolyte itself starts to corrode and the crust thickens fast. Hold it half full, and the anode relaxes a fifth of a volt higher, the reactions starve, and the cell barely ages. That is why your new phone ships near a third charged, and why parking a laptop or an EV full for months quietly burns through its life. Now watch what happens when you actually use it. Drain that cell to empty, and back, over and over, and the crystal grains swell, shrink, and crack apart, gone in maybe 400 cycles. But sip from it gently, just a tenth at a time, and the same cell can breathe tens of thousands of times. Same chemistry, 50 times the life. How deep you go matters more than how often. Speed punishes it too. Push current in too fast, and lithium piles up at the particle surface faster than it can burrow inside, building a steep concentration cliff. When that surface saturates, the anode's voltage dips below 0, and lithium stops tucking in and starts plating as raw metal, worst when cold and nearly full. One quick top-up is harmless. It's the constant, flat-out fast charging and heat that does the damage. And there's one more trap, the most dangerous of all. Charge that battery below freezing, and the lithium can't slip into the graphite fast enough. So it does something deadly instead. It plates out as raw metal, growing branching, frost-like dendrites that creep toward the other side until one of them touches, and the cell shorts. The cold itself is harmless. Charging in the cold is what bites. So with the real physics in hand, let's kill 3 myths everyone believes. There is no memory effect to feed. That was old nickel-cadmium crystals, not lithium's intercalation. You cannot overcharge a modern cell. The management chip clamps the voltage and cuts off near 4.2 volts. So overnight is fine. And do not drain to 0. Deep discharge is the stressful one, while shallow partial cycles last several times longer. Now forget the lab. Look at the receipts. Across hundreds of thousands of real cars, the average Tesla still holds about 85% of its range after 200,000 miles. One Finnish taxi kept 93% past 400,000 kilometers. Fewer than 1 in 100 newer EVs has ever needed a new pack. Your phone follows the same quiet rule, roughly 80% left after 500 to 800 full cycles. The physics, it turns out, is on your side. Everything you've seen comes down to 3 habits. Keep it cool. Heat is the #1 killer, doubling the aging rate for every 10 degrees. Live in the 20 to 80 band, not pinned at full or run flat. And for long storage, leave it resting near half. Do these three things in the same cell can last 2 to 3 times longer. But every rule has its rebel. Lithium iron phosphate locks its oxygen inside an olivine cage of iron and phosphorus bonds. So it shrugs off the heat and high voltage stress that wear other cells down. It survives thousands more cycles, and its voltage stays so flat that you actually should top it to 100%, letting the battery's brain recalibrate against the only landmark it can see. But here's the beautiful part. Do the opposite of everything you just saw. Keep that same cell cool, rest it near half charge, and almost nothing happens. Ions shuttle gently back and forth. The SEI grows whisper thin and nearly stops. This is why a Tesla pack can still hold about 85% after 200,000 miles, and why barely 1 in 300 modern EVs ever needs a new battery. Treat it kindly and it stays young for a very, very long time. The chemistry was never your enemy. You just had to learn its rules. Subscribe and let's uncover the next hidden universe of physics together.